So I'm a professor at the Ohio State. I'm a horticulturist and then also a little bit of engineering background and usually work in greenhouse, but this collaboration brought me, in this learning opportunity for us too, to work in high tonal. So I'm actually looking forward to seeing Brad's high tonal tonight. So all right, so some of the topics I like to cover, if it is too technical, please ask questions, then I'm happy to answer, or maybe after the event, you can email or call me, then I'm happy to answer. So the title today is a tabletop strawberry root zone management. So this is a kind of diagram how the root zone in a substrate-based production system might look like. So here you have a, the source water, and then nutrient solution is injected, and usually high concentration. So that in the water stream you have all the fertilizer in it. And then that fertilizer using a drip or emitters going through the root zone, and then that is draining out, we call drain. And then that nutrient stream is very important because it provides nutrients, of course, and then water, and then one more important thing is oxygen. Oxygen in the nutrient solution is basically providing necessary air or the oxygen in the root system. And then this is how Brad's greenhouse started. I mean, not greenhouse, high tonal. Okay, so here is the gutter, steel gutter system, and then that's basically collecting drain, coming out from the bag. And then the bag is basically having the substrate in it. And then drip irrigation in his setup. This is the first day we planted. And then exactly the same system is used in the high-end greenhouse, for example, tomato production, cucumber production, pepper production, exactly the same. In this case, slab of cocoa, and then drip irrigation, spaghetti tube, and then steel gutter system. And then because a tomato and cucumber, they are very tall, so usually gutter is located very low level, but strawberry, usually gutter is like 3 feet or maybe 4 feet high, depending on how you feel comfortable, raised gutter system. And then this is my greenhouse in Columbus campus. This is also the planting day, September. Those plants started producing by end of November, and then we are still producing. Every week we have some fruits coming out. Of course, there are up and downs, but technically you can continue because we have greenhouse. But high tonal you have to manage, with weather and time you can produce. So that's a little bit different system. So soilless root zone factors, so important factors I listed up for strawberry. Because the root zone is, small compared to soil-based system, you have to meticulously manage considering all these factors: oxygen, moisture content, salinity level, pH, that's acidity, nutrient level, volume of that root zone, and temperature. So I would say whether you understand these and manage, whether you can manage those factors effectively or not would directly affect your yield. So it's very important. You can still grow plants, not paying attention too much, but the yield is directly affected, meaning your yield, if you don't pay attention, yield is not that great. So strawberries are very sensitive to these factors. And then so what are affecting these factors? So the substrate, what kind of substrate or horticultural mix you put in that container or bag, that would affect oxygen and moisture content. The same thing, like irrigation frequency and drainage, that would affect oxygen availability and moisture content. And then those chemical parameters or chemical factors, salinity, pH, nutrient, those are affected by nutrient solution formula, what kind of fertilizer program you have, or what kind of substrate, pH to start with, or what nutrients plants are taking up also affect those chemical parameters. And then air temperature and radiation in the high tonal would affect temperature of the root zone. So if you are doing an in-ground production in the soil has huge buffer, so you don't need to worry too much about soil temperature. But as soon as you are detached or the plants are detached and then the root zone is in the air, right, or the sitting on some kind of structure, then the root zone temperature goes up and down following air temperature. So, and then plants are responding to that. So you need to understand that fluctuation of the temperature. Mark, do you want to add something in this slide?
I was thinking while you're talking that strawberry responds sometimes quite slowly to some stresses in this categories. For example, if your EC is too high for too long, you wouldn't notice right away. Plants look fine, but after a week or so, they're going to start literally turning a gray-green color, and then you'll see leaf burn. And so we measure a lot, and the measurements keep us in front of those kind of stresses. You can't just look at the plant and say, oh, it's doing great, because 2 weeks later, you're going to have a lot of catching up to do. So we measure constantly, daily, monitor regularly, just to stay in front of problems.
Right, all right. And then, as I said, the substrate or horticultural mix is in some kind of container or bag. So I just selected a very, how do I say? Well, I would say available containers, and then also a type of bag used for strawberry. So the left-hand side here, what we call meter trough, it's a plastic trough, and then the volume is 16 to 17 liters, so that is 4 gallon or so. And we usually plan, we usually decide the number of plants to go in based on the volume of the substrate. We want to put about 2 liters, so the half gallon per plant. So this meter trough is about 4 gallon. So that means we want to put up to 8 plants, half gallon per plant. Smaller than that, plants get stressed. Strawberry plants really like to have a good root zone volume, and that seems to be a very important key. Now, this one is a small one, Strawberry Pot, Canadian, actually Dutch company, but the distributor is in Canada. It's selling this. It's only 3.6, so it's a little less than a gallon. So this is just for 2 plants by this pot. And then this one is a strawberry bucket. So if you have some kind of river or something, you can hang on that. So it's kind of, you don't need to have a gutter system if you're using this type of container. And then here's a bag. It's a plastic bag, and then holes are pre-made. And then this has actually 10 holes. So it's a little bit too many for me because it's only 16 liters. So that is, so that is 4 gallons. So it's a little bit too many. So we sometimes, sort of skip some of the holes and then just adjust the number of plants that way. But anyway, so those are the typical ones used in strawberry. And then substrates, what kind of substrate? Coconut coir is very common. And nowadays you can find strawberry cocoa or strawberry coconut coir sold from a horticultural substrate company. And then peat moss mixed with cocoa, mainly for pH control. Strawberries really like to have a low pH, so more peat usually bring the pH down. Perlite is quite important material because it would add air, air space in the root zone. Strawberry really like to have air in the root zone. So that's why we put almost 50% of perlite when we mix those three materials. So the 50% perlite and then maybe 20 or 25% of peat, depending on the pH, and then the rest is cocoa. So that's typical mix we do if we do mixing substrates by ourselves. And then the result of the mix look like upper right picture. All right, and then just showing how plants respond to different substrates, different mix of cocoa, perlite. You can see that some of the plants are big, some of the plants are kind of stunted because of the substrate. Because strawberry plants are very sensitive in the root zone, therefore you see that difference like this. And then next slide is a little bit too much information, but basically 4 different substrates we tested, and then the yield difference is up to 30%. So that's a huge difference just by selecting materials to put in. So you really need to pay attention substrate for strawberry. Mark, you have anything to add?
No, it is true. Substrate is probably one of the most critical aspects, choosing the right one. There are, as Jerry mentioned, coconut coir for strawberry, which have a mix of chunk and fiber and dust, and actually provide a lot of aeration and good water holding capacity. And there's other, like the top one has more components in it than just coconut coir. Works very well in our situations.
Yeah, but, and then I'm not talking too much about that, but it has a biological additives too, microbial additives. So mycorrhiza, and then also growth stimulating microbes, basically added, particularly in a commercial mix, and then that seems to work at, to enhance the growth. So root zone is very important, again, for strawberry. And then another thing, it's a little bit more complicated, but I showed you different containers, right? So the substrate mix, one thing you want to remember, substrate mix works really well for this, may not work for that or for this. So substrate and container needs to be optimized together. So you have to select the best substrate after you decide the container, or well, I think that's probably the most straightforward way to find. So find the container and then decide what substrate works the best. So going into the nutrient solution side, so this is just showing the difference between the parts per million of nutrients between different crop species. So I'm showing how tomato nutrient solution requirement, how unique that requirement is for strawberry compared to tomato or lettuce. And basically, compared to this one, tomato or lettuce, the concentration range is all, much lower than the other 2 crops. Strawberries do not like high concentrations of nutrients in the root zone, therefore typically grown very low concentration nutrients. So that is strawberry. So another thing is, see the tomato require a lot higher potassium, even lettuce, but strawberry doesn't need that high potassium. So that's also another unique thing. So now there are pre-mixed fertilizers designed for strawberry. So if you are not, familiar with mixing your own fertilizers to create strawberry formula, you can buy something like that, strawberry mix, and then just dilute with water. So that's easy solution. And then usually, because it's a substrate production, the root zone is limited. You have to provide not just all these macronutrient, but also what we call micronutrients, like those micronutrients. You have to provide everything because, again, root zone is limited and there's no buffer from the soil. So that's why you have to give everything.
So basically, if you're not familiar with injection irrigation, we use a concentrated stock solution that allows us to make up 100-time concentration of the solution, so that one, we don't have to make it up so often, and two, it keeps well. It doesn't grow algae or things like that at that concentration. And then there's many different kinds of injectors that basically take a little bit of that stock solution and put it into the feed water and dilute it to some amount, usually around 1 to 100 or something like that, especially if that's your stock solution concentration. As you see in this drawing here, they plumbed in bypasses, which are nice so that if you want to shut off an injector, that allows you to bypass that injector. Or nowadays, a lot of the injectors have bypass switches right on them, so you can shut off an injector if you need to. Solenoids are controlled by either a timer or some other controller that is measuring some kind of environmental property like light. So a timer requires a lot more of your management. So if it's a cloudy day, you need to dial your irrigation frequency back. If it's a very sunny day, you need to increase it. But there are irrigation controllers that measure light, and if the light is high, it irrigates frequently. If the light is low, it irrigates less frequently. Emitters are important to use pressure compensated emitters. Otherwise, you can have very different output along the drip line. I don't know how different it can be, but it can be very different. You don't want that. You want everything entering the plant to be the same for each plant. And then just usually you have a header and poly lines, and is there another picture after this?
No.
Okay, and then drip tube and a drip stake, and that's typically how you apply irrigation to containerized tabletop strawberry production. You could use drip tape if it matches your row, or a lot of drip tapes are pressure compensated and so would evenly provide an even amount to the containers. One nice thing about something like a drip tape is you don't have all that tubing in your way when you're trying to work on the plants. That can be.
Yeah, but if you're using bag, you have to have a.
Right, if you're using a bag, you have to have a drip stake.
Yeah, that's right. All right, so so one thing I want to introduce, this is something we use in greenhouse. It's a sort of standard setup. Again, root zone, understanding root zone is very important, and that's the key for the success of growing crop in greenhouse. Anything growing in that teeny tiny substrate, you want to understand what's going on in the root. So to understand that, you want to sample the nutrient coming out from the root zone, in this case, in this slab or bag. So we will explain but over there, but oh, that's right, here you don't have this. So like this short gutter system, it's probably not too difficult to collect the drainage from the gutter. but if the gather length gets longer, you probably want to have a separate setup, and then we call that lysimeter. So lysimeter is the independent setup, but same way, the left-hand side, that picture is a lysimeter, but it's designed for tomato, so that's why it's sitting on the ground. But you could set up something like that in high tonal, so that every day you can actually look at what is the EC and pH. EC is the electrical conductivity, so that's a salinity indicator. EC and pH, volume in the drainage or drain, and then also a little container you can see right here is collecting the amount of nutrient coming directly from the emitter. So what is in the feeding line? And then you got to understand the same values, same variables, EC, pH, and volume, drip and drain. And then I always say that you need to understand every day. If you don't do that, then you never understand what's going on. Because again, as Mark said, plants do not show the stress right away. So something wrong might show up in a month later. So strawberries are so it's kind of quiet plants. So that's why we always suggest do that every day. So that might be a big challenge for someone who has never grown substrate-based crop and then going into strawberry and then getting used to that requirement and workload to be successful. Right, so irrigation management, strawberry plants do not like too wet or too dry. So when you stick your finger in a substrate, it shouldn't be soggy. It should be moist, but it shouldn't be soggy. If it is too wet or soggy, then that means plants do not have enough air in the root zone or oxygen in the root zone, so that would limit root growth. And then if it is too dry, then of course strawberries are under the drought stress. And then some of the tips for the irrigation, we never put too much water all at once. We put teeny tiny amount of water or irrigation nutrient solution many times a day. So that's a very different way compared to soil-based production system. So we use emitters, half gallon per hour emitters, pressure compensated, and then usually set the run time from 1 minute to 2 minutes. That's it. So that gives only 33 milliliter to 66 milliliter. So that's teeny tiny amount, right? Per time, but plants need probably somewhere between 5 times or 4 times of that, depending on the season. But you want to spread those irrigations over the day, rather than put everything at one time. That way, the root zone, all the water and pH and everything maintain relatively stable, rather than big flash, big dry. And then another key for the successful irrigation management is maintaining drainage rate coming out from the root zone, about 20-30% of what you are providing. So that's another important thing to be successful in this substrate-based production system, 20-30% daily drainage rate compared to what you are providing to the plants. And then, again, everyday measurement of volume of the solutions, drip and drain, pH and EC of the solutions. And then right-hand side, I'm showing the sensor. This is a twin sensor. So the one machine, and then you can read EC and pH. It's probably the expensive, so this is probably $300 or so, Mark? Less than that?
That one was less than 2.
Less than 200.
I
Okay,
think.
so that's good. So yeah, but you know, it's a not cheap, but it's very important to have this. And then we try to maintain, see the drain pH and the EC in certain range that we believe are the optimum range for strawberries. And then if it is getting off, you have to either wash off with water or change the solution concentration or increase the solution concentration. So that's why you have to measure the drain every day. So this is just a little technical, but showing the strawberry oxygen requirement is much higher than other crops, we know very well. So that is basically justifying why strawberries are so sensitive in the root zone, particularly oxygen requirement, you know, the aeration or the what we call porosity is very important in strawberry, more than so than other crops we know. All right, so Mark, this is the last slide, but you probably more
this
familiar
was
with
something that we discovered early on in the learning the process of greenhouse starter reduction is as you're measuring a crop that's reasonably well managed, things like your drain EC, your drain pH volumes kind of stay the same. And then we were experiencing this huge crash in pH where it just went down, 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 down. And I related that to an extremely heavy fruit load. And that heavy fruit load basically stopped the plants from growing. We had no new leaves. And so without vegetative growth, there's very little nitrate uptake, which helps pH be high. And also without sufficient vegetative growth, roots tend to stop growing and they start to degrade. So you're getting tissue degradation and some organic acids in there too. And so what I had to do is I went and pulled a bunch of fruit off the crop, and that's just emphasizes the importance of some fruit load management as well, but had to flush it. The flush is referred to flowering fruiting, not running irrigation through. So first flush is flowers and fruit. Second
this one
flush.
is, yeah. It's
In a typical ever-bearing system, you might see your second flush of fruit be very heavy. And you're thinking, great, but you really have to manage that fruit load, otherwise you can run it. But
Yeah,
anyway,
you
but
can't
pH
see-
can be an indicator of something that's wrong.
Yeah, so you
with
can't see here because it's a teeny tiny font, but this is pH 4.5 level. And then this line, lower line is 5.5, upper line is 6.5. So those are the sort of upper and lower range we consider optimum. So this is way below.
Yeah. So you can see these peaks. It was going down, so I was like basically just flushing with our Arizona tap water, which has a lot of alkalinity and high pH, and bump it up and bump it up and bump it up, and finally figured that wasn't working. We had to manage the crop aerial fruit leaf portion.
Yeah, so we do that. All right, so yeah, so that's the sort of overview of the typical challenges when you are doing this or trying to do that first time in substrate production. Regardless, I would say, tonneau, greenhouse, regardless. So we have website for strawberry. This is a second from the left. So this is an indoor berry website. All the key information there, not necessarily geared toward high tonals, but principles and basic information is applicable. So if you're interested, lots of hands-on videos also in that website. And then again, you are always welcome to email either me, kubota.10, or Mark, krogo.4, osu.edu. So, well, thank you so much.